All right, good morning, everyone. Buenos dias. It's my privilege to kick off our day number 2 from our colleagues at the International Association for Research on Cancer. For those of you that may know, IARC is a agency within the World Health Organization and looked to us on the world stage for guidance and recommendations on cancer information. Today and this morning, we have a presentation from IARC led by Dr. Mary Schubauer-Berigan, who is the head of the Monographs program at the International Agency for Research on Cancer, where she leads work to evaluate the causes of human cancer. From 1999 to 2018, she worked with the United States Institute for Occupational Safety and Health. Mary's area of expertise is in occupational epidemiology. She has conducted extensive epidemiologic research on health effects of low-dose ionizing radiation, radon, beryllium, and carbon nanotubes. In 2010, IARC released the monograph that looked at how firefighters, painters, and shift workers were impacted by cancer, classifying them as a group 2B carcinogen. Today, we go a little in depth and try to explore our understanding of how this monograph is put together and how it informs our efforts in firefighter cancer control around the world.
Nominations are made by scientists, by government agencies, and since 2003, by the general public. Priorities are identified with the assistance of an advisory group, which is convened every 5 years to review the nominated agents and to recommend a series of these agents with high, medium, and in some cases low priority. However, the selection and timing of the evaluations is determined by IARC in consultation with our partners elsewhere in WHO. An advisory group was convened in March of 2019 to review more than 170 nominations that had been made by the general public. Resulting more than 120 agents were recommended for high, medium, or low priority for evaluation by the program during 2020 to 2024. These agents include agents previously evaluated by the IARC monographs, which are shown at the bottom of this figure, as well as agents that have never been previously evaluated. In a summary publication in the Lancet Oncology, this table presents the rationale for each of these agents in terms of the evidence stream that provided supporting evidence for either a new evaluation or for a reevaluation if it appears that the classification could change. As noted in this figure, the list of prioritized agents includes a wide variety of chemical, biological, physical agents, as well as complex exposures, mixtures, exposures of everyday life and occupational circumstances. There's also a public engagement process that happens during the development of each monograph. The monograph's meeting is announced approximately 1 year in advance. A preliminary list of agents is posted online on our website, as well as a declaration of interest for IARC WHO experts is used to ensure that we have public confidence that interested parties do not have links to the working group. So IARC strives to identify and avoid all conflicts of interest in carrying out our meetings. These could include employment, research, and financial interests. They must be declared before the official invitation is proffered, and they are updated before the evaluation meeting. The pertinent interests are disclosed to meeting participants as well as to the public and in the published monograph. Working group members, importantly, also complete a conflict of interest form that is required by the Lancet Oncology for publication of the short summary after the meeting. We'll go into now some information about meeting preparations. The monographs are a systematic review undertaking, which has 5 steps. Step 1 is to identify relevant information. Step 2 is to screen, select, and organize the studies that are being evaluated. These first 2 steps are carried out initially by the Secretariat and then are finalized by the working group. In steps 3 and 4, the working group evaluates study quality and reports on study characteristics. Step 5 happens during the in-person meeting, and it is here that the evidence is synthesized, first by evidence stream, and then overall, to reach a conclusion about the carcinogenicity of the agent under consideration. Studies and study designs. This shows an example of one of these bubbles in the first image, indicating the tags that are assigned to each of the table builder software, which was developed by IARC in consultation with our partners elsewhere to document the data that exists in these types of studies. The tables are published within the monograph together with the text that describes each study. Step 5 is to synthesize the evidence and to reach an overall evaluation. This happens as a deliberative process during the monograph meeting. Evidence in 3 different streams is considered. First, cancer in humans. Second, cancer in experimental animals. And mechanistic evidence. For cancer in humans and cancer in experimental animals, 4 categories of evaluation are considered. First, sufficient evidence. Second, limited evidence. Third, inadequate evidence. And fourth, evidence suggesting lack of carcinogenicity. For mechanistic evidence, the 3 categories are strong, limited, and inadequate evidence. with strong evidence having 3 different subcategories: mechanistic class, the key characteristics of carcinogens, and a determination that a mechanism operating in animals is not relevant to humans. These 3 categories will be described in greater detail very shortly. Now we'll take a closer look at the different subgroups that are involved in the Monographs meeting. Subgroups 1 and 2 are engaged in the exposure characterization and in the studies of cancer in humans. Subgroup 1, exposure characterization, is concerned with the identification of the agent, the detection and analysis methods for the agent, data on production and use of the agent, any published information on exposure, and regulations and guidelines for that agent. Lastly, a critical review of the exposure assessment in key epidemiological studies of cancer and of mechanisms is undertaken by Subgroup 1. What's new in the revised preamble? The preamble reinforces the descriptive aims of this section and calls for enhanced coverage in low and middle income countries. In addition, there's a new section added on this critical review of the exposure assessment methods in epidemiologic studies. Subgroup 2 is concerned with studies of cancer in humans. Here, the subgroup undertakes causal inference for the body of evidence of human cancer, accounting for study quality and study informativeness. As noted previously, there is increased attention to the quality of the exposure assessment. New features with the revised preamble are the enhanced use of systematic review tools in evaluating studies, as well as explicit consideration of study informativeness, as well as study quality in weighing the evidence. There is also increased emphasis on working groups' evaluation of the impact of bias and confounding in the context of cancer hazard identification.
So for the subgroup 3, which evaluates studies of cancer in experimental animals, this is really looking to the evidence of an increased incidence of malignant neoplasms, or an appropriate combination of benign and malignant neoplasms in high-quality studies. What's new in the revised preamble is now it's eligible to include genetically modified animals in studies therein, such as the TGAC mice and mice with targeted expression of viral genes, as well as humanized mice that may be implanted with human cells normally infected by the virus. Now, the subgroup 4, evaluating mechanistic evidence, has undergone a major revision. And so I'm going to spend a little bit of time describing this and giving you some of the background about it. This subgroup considers the strength of evidence for 3 topics: mechanistic class, the key characteristics of carcinogens, and the relevance of the mechanism for tumors in animals to humans. A lot of this review is focused, of course, on the study quality. So what's new is really driven by a number of challenges that were identified during the Volume 100 review that was undertaken by the IARC Monographs. This considered all of the known human carcinogens, those in Group 1. And as you can see from the cover of this book, these include a number of different agents that encompass metals as well as chemical agents, complex mixtures, occupations, and in the review of the diversity of these agents, these challenges were identified. First, it wasn't clear how to search systematically for data relevant to mechanisms. And this led to a lack of uniformity of the topics considered across mechanisms. In addition, the mechanistic data can be very voluminous as well as diverse, coming from studies in humans, studies in vivo in animals, as well as in vitro and QSAR modeling studies. And in all of these led to the last challenge, is how to avoid bias towards a favored mechanism in reviewing the mechanistic data. So in workshops convened by IARC, this concept of the 10 key characteristics of carcinogens was brought to the fore by Professor Martin Smith, who's at the University of California at Berkeley in the United States. These are the chemical and biological properties of the established human carcinogens, and therefore data on them can provide evidence of carcinogenicity. They can be used to assemble the data relevant to mechanisms of carcinogens without needing an a priori hypothesis of the mechanism. So this list shown here of the key characteristics really encompass the properties of the diverse carcinogens that we know cause cancer. And as shown next, this can be visualized in here. And if you think about a carcinogen such as ethylene oxide, which is shown in the upper right quadrant, it's a reactive electrophile. It binds to DNA. It's genotoxic. So it has those key characteristics. Other carcinogens, such as immunosuppressive drugs, are immunosuppressive. And so they have the key characteristic number 7. Viruses are a different type of carcinogen, and they have the properties of causing immortalization and also altering cell proliferation, cell death, or nutrient supply, the 9th and 10 key characteristics. And listed on this slide are several publications elaborating the relevant biomarkers and assays by which we can measure the key characteristics that are considered in IARC monographs. And for more information, we've also established a website where you can find more about ongoing projects in this area. So the key characteristics can be used to interrogate high throughput and high content data, and this has been done in recent volumes in the IARC monographs. So now we're going to describe how the evidence is synthesized and the overall evaluations are reached. Previously, this was done by considering the evidence of cancer in humans and the evidence of cancer in experimental animals, and then using the mechanistic evidence to up or downgrade those evaluations. In the revised preamble, this is now considered to be a single-step integration where you can literally read across this table to reach the evaluation. Another change is that previously there was a group 4, which has now been eliminated and merged into group 3. So there are 4 possible classifications. Group 1, carcinogenic. Group 2A, probably carcinogenic. Group 2B, possibly carcinogenic. And group 3, not classifiable. Another clarification in the preamble is that group 2B is really based on one stream of evidence, either limited evidence of cancer in humans, sufficient evidence of cancer in experimental animals, or strong mechanistic evidence. Whereas group 2A is based on a combination of 2 streams of evidence, and at least one of these needs to be in human primary cells. So some examples are limited evidence of cancer in humans in combination with sufficient evidence of cancer in experimental animals. Also, there can be limited evidence of cancer in humans in combination with strong mechanistic evidence. Another possibility is to have sufficient evidence of cancer in experimental animals and strong mechanistic evidence in human primary cells or tissues. So the key characteristics that were previously described can have an impact on evaluations in group 1 when they are found in combination with sufficient evidence of cancer in experimental animals. This is not a new method of classification in the IARC preamble. However, they can also have an impact for group 2A with strong evidence in combination with limited evidence of cancer in humans, or when that strong evidence is in human primary cells or tissues, in combination with sufficient evidence of cancer in experimental animals. Importantly, it's also clarified that strong evidence, including evidence in experimental systems alone, can lead to a classification of Group 2B. So now I'll review some example classifications that are based on two evidence streams. So when the evidence of cancer in humans is less than limited, it is still possible to make classifications based on the other two evidence streams. And these examples are shown here. It's also possible to make classifications when the bioassay evidence is less than sufficient, using the combinations of evidence of cancer in humans and mechanistic evidence, or those data streams alone. In addition, when the mechanistic evidence is less than strong, there are classification possibilities based on evidence of cancer in humans and evidence of cancer in experimental animals, either alone or in combination. After the evaluations are reached, the IARC monographs, together with the expert working group, publishes the results of the evidence synthesis and the consensus evaluations in the Lancet Oncology. This is done very soon after the evaluation meeting and provides a scientific summary of the evaluations.
The monographs are published online about 9 months after each meeting, and some examples of these are shown here. Each monograph is made freely available online via the publications page of IARC and is also accessible through WHO's publications page. They're also published on the NCBI bookshelf, which provides increased visibility as well as recognition of authorship for all of the working group members. Hazard communication occurs at all levels for the IARC monographs, from institutional communications through major media outlets, in some instances through public conferences, as well as scientific seminars. Recently, we have begun to print infographics for each monograph meeting. These succinct summaries provide graphical illustrations of the monograph's evaluations and help to educate the public about the importance of the evaluations. Here are some examples of monograph staff at work educating their peers and the public about the results of monographs programs. We would very much like to acknowledge the advisory group to recommend an update to the preamble for the IARC monographs. We also wish to acknowledge the staff and scientists of the IARC monographs program, who are all listed here, as well as the scientific editing and technical team who are responsible for document management and monographs production. The IARC monographs have received funding from the United States National Cancer Institute and the National Institute of Environmental Health Sciences, as well as the European Commission Directorate General for Employment, Social Affairs, and Inclusion. We thank you for your attention.